this is the second question that we are going to solve in the topic, and let's mark it question number 2. So question number 2, and let's mark the dimensions as well. So let's keep the dimensions which we were previously using in the previous question. So this length is going to be 100, this height is going to be 20, sorry, this height is going to be 20, this side is going to be 80, and this side is going to be 20. So this is the diagram. So our steps include, first thing is to define the reference axis. So this is going to be y, on this side it is going to be x. So once we have defined it, we have already discussed before, what we need to do is to make a table which will keep our workspace clean. So there are two geometries, geometry 1, let's keep it geometry 1, and geometry 2. We have already discussed number of rows is equal to number of geometries plus 1. So first column is geometry, second column is area, and let's keep this in centimeter. So area in centimeter square. Then we have xi centimeter, and then we have yi in centimeter, right? Let's make our table geometry 1 and 2. Now let's try to fill the table, the vacant spaces. What is the area of first geometry? So height is 80, breadth is 20, so 80 into 20 is 1600 centimeter square. And for the second area is 100 into 20, that is 2000 centimeter square. Now x1 is the centroid of the first geometry with reference to the reference axis. So we see that this geometry is in contact with the left side of the reference axis, so the distance will be only half of what we have here. We have already seen this in previous videos. So just remember the formula and let's try to put the values here. So half of 20 is 20 by 2, that is 10. And then y1 is centroid of the geometry 1 in y direction. So again you can see this is in contact with x direction, so it will be half of 80. So 80 by 2 is 40. Now same thing with area 2. Now in area 2, the extreme left side is in contact with the reference axis, so it will be half of the distance of the geometry. So 100 by 2 is 50. And then comes y2. Now y2 is a little tricky, but not little tricky, we have already seen this in the previous video. So first try to find out the location of the centroid with reference to its extreme axis, or in this case bottom axis. So if the entire height is 20, the distance of the centroid within the geometry will be half of 20, and plus the distance between this point and the reference axis is 80, already given here. So plus 80 is equal to 90. Let's put the values in the formula. The areas are being added. So x bar is equal to a1 x1, so 1600 into 10, plus areas are being added, 2000 into 50 divided by 1600 plus 2000, and y bar is equal to 1600 into 40 plus, since the areas are being added, 90 into 2000 divided by 1600 plus 2000. So let's find out the values. But now, what if I tell you this problem can be solved by another way also, in which now we are not considering the two rectangles are being added. Now in the second solution, what we are going to do, we'll assume that a smaller area, that is this side, this portion, is taken out from a larger area which was of dimension 100 into 80 plus 20, 100. So, and this one is again 80. So a small square is taken out of the bigger square. So this is going to be my geometry. So this is being taken out from a bigger geometry. So we know the drill. Let's make a table. So number of rows again will be 3 and number of columns will be 4. Geometry, area, centimeter square. Then we have, we have xi in centimeter, and then we have yi in centimeter as well. So remember, this method is subtraction method. So we have two geometries, geometry 1 and geometry 2, and let's fill the unknown values, the blank values. So area, bigger area is, remember, breadth is 100, depth is 80 plus 20, 100. So 100 into 100, that will be 10,000. And then we have a smaller area which is height of 80, and for length if you take out 20, the breadth also becomes 80. So smaller area is 80 into 80, that is 6,400 centimeters square. Now x1, I am taking the bigger geometry as 1. So x1 will be, see, the extreme left side of the image is in contact with the reference axis. If the entire width is 100 centimeter, then xi will be 50, and this will be because it is half of 100. And then y1, same thing. Similarly, the extreme bottom part is in contact with the reference axis. Height is 100, so y1 is 100 by 2, that is 50. Now x1, remember x1, the extreme edge of the small square is not in contact with the reference axis. So first try to find out the location of the centroid. So if the entire width is 80, the location of the centroid is 80 by 2, and then we have to add this distance. This distance is given as 20. So 40 plus 20 is 60, right? And then we have x2 and then y2. Y2 is very simple because it is in contact with the reference axis. Total height is 80, so it will be your 80 by 2, that is your 40. Now putting this value in the equation, now remember this portion, this method includes the subtraction of the area, and hence we'll have to put the values, use the term subtraction. So x bar is 10,000 into 50 minus 6,400 into 60 divided by 10,000 minus 6,400, and then we have y bar, which is 10,000 into 50 minus 6,400 into 40 by 10,000 minus 6,400. So upon calculation, you guys will find out that these values x bar using the addition or subtraction method will be the same, and the y bar value using the different method will be the same. We'll see the solution in the next video. This video has already been extended to a very long period of time. Okay, almost 10 minutes. So see you guys in the next videos. Try to solve this, bring the solution by your own, and then check the next video to find out whether your calculations are right or not, because you need to do practice on your calculation skills. Okay, so see you guys in the next video. That's all for this one.